Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called So Long Sums by PageDo. And I'm not sure if it makes sense because we have very long sums here. And are we saying that we're not doing any more so long sums? We are actually starting these so long sums, right? But anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits along arrow lines summed to the number in the circled cells. Multi-cell numbers are read from left to right or from top to bottom. Arrow lines are colored to distinguish different arrows. So the sum of these three digits, which this being the hundreds digit, this being the tens digit, this being the ones digit, must add up to the digits which are along its arrow, which is basically every other, oh, it's not every other digit. It's every digit up to here, interestingly enough. And this three-digit number, with this being hundreds, this being tens digit, and this being the ones digit for that number, must sum up to what all of these arrows, or all the digits along these arrows, what they sum up to. That's interesting. I don't really want to give an example because that will start solving things, but that's an example of how these are usually called pills too. This is normally how pills and arrows work. This is a two-digit number with this top digit being the tens digit and this bottom digit being the ones digit. So keep that in mind also. We also have digits in cells joined by an X summed to 10, and digits in cells joined by a V summed to 5. And digits in cells joined by a white dot are consecutive, and not all X's, V's, or dots are necessarily given. So, for example, if say this was a 3, this digit would have to be 7, and this digit would have to be 2, because these two digits must add up to 10 because there's an X in between them, and these two digits must add up to 5 because there's a V in between them. As an example of how the white crop key dots work, if this was, say, a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first thing I see is these blue arrows summing to, these two digits must sum to 10. These two digits must sum to 10. 10 plus another digit is never going to be more than 19 or less than 11. So this is guaranteed to have a 1 here in the tens digit, and this must have a 1 here in the tens digit here. So this is 1, which means this adds up to 5. So 1 and 4 add up to 5. 4 and 6 add up to 10. So this is 6. This can't be 4 or 6, and this digit must be the same as this digit, which must be the same as this digit. Because these two add up to 10, that means 10 plus this digit is obviously 1 plus that digit, or sorry, 1 in the tens digit plus that digit. So we know this is, whatever this digit is the same as this digit, which is the same as this digit. 6 is consecutive with 5 or 7. If this were 6 and 5, the problem is that's only consecutive with 4 remaining because we already are consecutive with a 6 here. So 6, 5, and 4 does not work because of the 4 in the row. So this must be 6, 7, and 8. So this is going to be 87. So one set of adding up to 45, two sets adding up to 45, three sets adding up to 45. So that's 45 times 3, which is 135 so far, that this arrow adds up to. Well, that's 135 plus 10, 145. And this is only 5 digits at most. And this is 4 digits at most. That means this adds up to 30 and 35 at most. So the max number we can have here would be, I think, so it's 145. You can't actually have 7 or 8 here. So the max actually is less than that. It's 2359. Yeah. 2359, which is 19. So 145, because these are 3 rows which fully are on the arrow, so they must add up to 135, which is 45 times 3. Plus the 10, plus the at most 19. So 145 plus 19 is 164. Plus a guarantee at most 35. 164 plus 35 is 199. So this can never be 2 here. So it cannot be 287. It's guaranteed to be 1. So this is 1. This is 4. That forces this to be, and this is a 1-4 pair. That eliminates 1-4 as a possibilities for the other V here. So this must be 2 and 3. These digits are consecutive. We only have 5, 6, 9 remaining in this box, and 5 and 6 are consecutive. So this cannot be 9. This is 9 here then. Remaining digits in a row 1 are 2, 3, 5, and 9, which is exactly adding up to 19. So again, these add up to 135. 135 plus 10 is 145. Plus 19 is 164. So 187 minus 164 is 23, but that's not restrictive, so okay. These two digits add up to 5, and they cannot be 2 and 3 because that would eliminate all possibilities for this cell. So this must be a 1-4 pair. Since this is a 1-4 pair, these two digits, which add up to 5, cannot be 1 and 4, so they must be 2 and 3. So that means it's 2 and 3 here, which makes this 7 or 8. We know, again, these are 3 rows here, which add up to 135. This is at most, so these are 10. There's another 10 here. This is at most for any digits. Well, we have minus 10 and then 1, technically. So this could be 11 at most. So 135, so this is 45 here minus 11 at minimum 11. So that would be 34 here. But we're guaranteed this can't be 2 or 3 because of a 2-3 pair in the box. So this has to be a 1 here. Because you can't have 400 for 3 rows and, a little bit extra in 2 other rows. Because 5 rows can only add up to, at most, what is it? 45 times 5. which would be 225. So, and we can't have 2 and 3 as the 100th digit, so this must be 1. So this is 1 and 9. Okay, that means this is a 2-3 pair. These two digits add up to 10. We can't have 1, 9 here. We can't have 2, 8, or 3, 7 because of the 2-3 pair in the box. This one eliminates 1 here, so this is 4 and 1. So this has to be a 4, 6 pair to add up to 10. And then the remaining digits, these digits are consecutive. 5 is not consecutive with 7 or 8, so this is 7 and 8 here, which forces this to be 2 or 3. Therefore, this is 195 here. Okay, so again, these add up to, what is it, 135. And these add up to 45 minus 15, which is 30. So 135 for these, plus 30. So interestingly enough, these two add up to 10 also. So it's plus 30 is 165. So these 5 digits add up to 30 also. Okay. 9 eliminates 9 here. 5 eliminates 5 here. 5 and 6 are consecutive with 4, 5, 6, or 7, but this can't be 4 or 6 because of the 4, 6 pair in the row, so this is 5 and 7. 5 and 7 is only, then, consecutive with 6 out of 5 or 6. So this is 6, this is 5. 5 or 7 is consecutive with 4, 6, or 8. Cannot be 6 here, so this is 4 or 8. Okay. So these are going to be 2 digits which add up to 10. So we'll mark that as orange and orange. This is 2 digits adding up to 10. We're going to make that yellow, and this is red. These 2 digits add up to 10. They cannot be 4, 6, or 3, 7. So this is 1, 9, or 2, 8 here. Obviously, 1 can't be here, so this can't be 9 there. This orange cannot be 4 and 6 as a pair. So it has to be 2, 3, 7, or 8 here. Okay. This cannot be 4 and 6. And it can't be the orange 2, 3, or 7. 2, 3, 7, 8. Can't be 1, 9. So this must be the other 2, 3, 7, 8, and not the orange one. Well, we know one of these is 2, 3, 7, 8. And this one cannot be the same as that, but it can't be the same as the orange either. So this cannot be 2, 3, 7, 8. This has to be the 4, 6 pair. This then must be the red 2, 3, 7, 8. And if we had 7 and 8 here, that would eliminate both possibilities for this, right? Again, this cannot be 1, 9 adding up to 10, cannot be 4, 6 adding up to 10 because of the 1 and the 6 in the column. And if this tried to be 7, 8, that would eliminate all possibilities now for this 10 set. Oh, and this can't be 7, 8 because of the 7, 8 pair in the row. So this must be 2 or 3. This can't be 2 or 3. This is then the orange 2 or 3, which is with the orange 7 or 8 here. This is the red 7 or 8, so this must be the red 2 or 3. This is red 2 or 3. This can't be 2 here because, or 8 because of a 2, 2, 3, 7, 8 quadruplet in the row. So this has to be 1 and 9. This is 2, 3, 7, 8. This can't be 7 or 8 again, so this must be 5 and 4. That means 5 cannot be here in this box. This 2, 3 pair eliminates 2 and 3 in the rest of the column, so this is 5 or 9. These cannot be 4 and 6. It could be 1 and 9, though. Okay. Um. Hmm. Remaining digits in row 7 are 4, 5, 6, and 9. Okay. 4, 5, 6, 9. 4, 5, 6, 9. 4. Okay, so this cannot be 4 or 6 because of the 4, 6 pair in the box. This is 5 and 9, which eliminates 5 and 9 in the rest of the row. This can't be 4 because of 4 in the column, so this is 6, which makes this 4. This must be 2, 3, 7, 8 remaining in this lower central box. We don't know which one's which, though. That leaves this 2, 3 pair and 2. So 2, 3, and 8 eliminate 2, 3, and 8 here. So this must be 7 and 3 to add up to 10. That means this is 3 and that's 7. This is 3 and that's 7, which makes that 3, which makes this 8 and 2. So this cannot be 3 or 7. This is 2 or 8. This can't be 3 because of a 3 in the box, so one of these is 7. Obviously, again, this is 2 or 8, this is 2 or 8. This can't be 3 or 7. We have 2 or 8 here. Remaining digits in the lower left-hand box are 2, 5, and 8, but this can't be 2 or 8 because of the 2, 3, 8 triplet in the column. So this is 5, this is 2 or 8 here, and these are both orange, obviously. Okay, so let's remove the coloring. We just need to know that so this has to match this one, so this cannot be, this is orange here, orange here. Orange cannot be here or here, and we definitely know it can't be here because of 2 and 8 are here, so one of these two is orange. Remaining digits in column 3 are 2, 4, and 8. 4 cannot be here. We don't know about this. Remaining digits in column 9 are column 4 are 2, 8, and 9. I was thinking of the 9 that had to be in one of those boxes. This cannot be a 2, 8 pair because of the orange that's here. Cannot be 4 and 6 because there's a 4 required. Okay, this 4 eliminates 4 here. So this is 6 and 4. Because of this 4, this cannot be 4 and 6. So it could be 1, 9, with this being 1 and that being 9, or 3, 7. We don't know which. Okay. This can't be 9 because of 9 in the row. So this has to be a 3, 7 pair, which eliminates 3 and 7 in the rest of the column. This can't be 3, this can't be 7. Where is the 7 in this lower central box? It has to be here. So that's 7 there. We have in this upper central box a 2, 8, 9 triplet, which eliminates 2, 8, 9 in the rest of the box. So this can't be 2, 8, 9. It's 3 or 7. It cannot be 7 because of the 7 here. So this is 3. This 7 eliminates 7 here, so that's 3 and 7 there. 3 eliminates 3 here, so it's 2 and 3. Remaining digit in row 3 is an 8, so this is 8. We have a 2, 8, 2, 8 pair in column 6, which eliminates 2, 8 in the rest of the column. This can't be 2 then, so this is 9, which means this can't be 9 here. This 9 eliminates 9 here, so this is 5 and 9. Where is the 9 in column 4? It has to be here. Remaining, so this 9 eliminates 9 here, it's 5. This can't be 5 or 9. This 3 eliminates 3 here, so this is 2, which makes that 3. Okay. Again, these must add up to 30. We do not have a 9 in these 5 digits. What is the max these digits can add up to? It has to be 8, 7, 6, 5, 4, which adds up to exactly 30, which is what we need here, right? Because this adds up to 30 here. 30 plus 135 is 165, plus another 30 is required to add up to 195. So this must be 8. All the oranges are 8 then. And this must be 6, 7, 4, 5, 6, 7 to add up to 30, which eliminates 4, 5, 6, 7, 8 in the rest of the row. This can't be 4 or 8, so this must be 2, which makes this 8, which makes that 4. That leaves 1 and 3 remaining here. This can't be 3 because of 3 in the column, so this is 1, which makes that 3. This can't be 4 or 7 or 5, so this has to be 6 here, which eliminates 6 here. This can't be 4 or 5 because of 4 or 5 in the column, so this is 7. No 5 or 7 in the column here, because so this is 4, which makes this 5. 4 eliminates 4 here, so it's 6 and 4. Again, these have to be 2 remaining. So let's just double check this, which is 135 here. 145, 155, 164. So this must add up to 23, 10, 23, which it does. Okay. These digits are consecutive. They cannot contain... Actually, yeah, where is the 1? In column 6, it has to be here, so 1 has to be consecutive with 2. That leaves this digit as a 5. We have 8 ones. We know where the last one has to be. It has to be there. We should have 8 twos also, which we do. We know where the last 2 has to be. It has to be there. We have 9 threes, so that's fine. We have 9 fours, that's fine. We have 8 fives. We know where the last 5 has to be. It has to be there. 6s. We don't have enough information about 6s. 7s. Where's the 7 in column 8? Cannot be here because of the 7s in the boxes, and these are filled out. So 7 has to be here. We have 8 7s now. We know where the last 7 has to be. It has to be there. 8s. We have 8 8s. We know where the last 8 has to be. It has to be there. 9s. In this right central box, 9 cannot be here. The only other space possible is here. Now, in this left central box, 9 cannot be here anymore because of 9 in the row, so this must be 9 there. And we have 8 9s. We know where the last 9 has to be. It has to be there. And I think the rest are 6s, right? So that would be 6, 6, and 6. And that's a solution. Yep, fairly straightforward. We were very restricted in what these lines could be. And it's just a lot of adding stuff together, really, with the X's and B's and the white Kropke dots. So, I don't know. I felt kind of straight. It was kind of straightforward. This is the first I've done that's had a 3-digit pill, at least in a while. I might have done one way back when. So I was kind of curious how this was going to work. It's fine. Nothing groundbreaking, but it was interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.